get a Laplace transformation of first order differential equation. So what I'm doing now is just to derive all this while I've been deriving equation. I've been deriving a formula. Previous time it was how to get the Laplace transformation of cos alpha theta, sin alpha theta, exponential at. I did how to get from exponential at. Also, I now derived the Laplace transformation of one. From there, I did derivation of a Laplace transformation of t raised to power of n. So now I want to derive a Laplace transformation of first order. So I'll do first order, second order, and third order. So mind you, this derivation of these formulas will be used for solving questions on the Laplace transformation. You understand? So yeah, they said find the find the Laplace find Laplace transform transform of df over dt. So this is df over dt is first order. So now I can obtain the Laplace transformation of this df over dt using Laplace equation. So Laplace equation now is your f of x is equal to integral from 0 to infinity. Then you have your exponential raised to power of minus st. Then you have your f of t times dt. So, but your f of t is your df over dt. So all you need to do is you substitute it into the Laplace equation. So we're going to have f of x will give you integral from 0 to infinity. You have your exponential raised to power of minus st. Then your f of t now is your df over what? dt times dt. So looking at this is what you're going to get now. So looking at this equation now, you're having two functions. The first one is exponential raised to power of minus st, and the second function is df over dt. So df over dt. So now I want to take my v. I want to take my v equal to exponential raised to power of minus st. So now I will differentiate this v with respect to what? T. So if I do that, I'm going to have the v over the t. So it will now be minus x exponential raised to power minus st. So why I'm having minus x? If you look at the power of this exponential, I have minus st. So, but the constant here is minus x. So it will not be, if you're differentiating v with respect to t, it will not be that constant minus x will multiply this exponential, and the same exponential will carry the same power. So when you do that, you're going to have it before. So we can easily get our dv now. Our dv will give you minus s exponential minus st times what? dt. Now we have gotten our dv now in the differential form. So now this my du is always equal to df over dt times dt. So the first one now, the first function, I take my v equal to exponential raised to power of minus st. So my second function now will be du now. It will now be in the differential form. Du now will be equal to the whole of this now, which is df over dt times dt. So this one now, the second function, I will give it du. So now if I have my d equal to this now, I can easily get my u. How do I get my u? So my u now will be very, very much easier. I can get it very, very easy. So now this one now, first of all I need to get I need to look for df over dt. So my df over dt is first order differential. So it's the same thing as say d over dt. Then you have f multiplied by what? F. So the f over dt is equal to d over dt multiplied by what? F. So this is first order differential. So now I want to use this value. I want to substitute the f over the t here from what I get here. I'll substitute it in this equation into du to get my du. So now I'll substitute this here, knowing that du is equal to df over dt times what? Dt. But the f over the t is equal to d over dt into f. We have into f. We have f. So finally, what I'm going to do is that I'll now substitute this into this. Then I'll have my du equal to d into dt, then multiply by f. Then I have dt here, dt, because my df over dt or df over dt is equal to d over dt multiplied by what? F. So if I substitute it here, then I'll have it here, du equal to d over dt multiplied by this f times this dt. So now this dt will cancel this dt. So I will now have du equal to d times f will give you the what? F. Will give you the f. So finally now I can easily get my u now. My u now will be like this will cancel this. So finally my u now is equal to what? F. Now I have gotten my u, I've gotten my I've no my du is known. I've gotten my u now. Now my v is known. My dv now is also known. So I'll use these things now. I will put these values into an equation. So what's that equation? Integration by parts. So the integration by parts will give you uv minus integral of v du. But I'm going to use u dv instead of this thing now. So let me just use u dv. I'm going to use this one to solve it. So now this one now will give you integration. This is integration by parts. Integration by parts. So based on my analysis, I want to use this equation now to obtain a Laplace transform of this first order, which is the f over dt. So now using this equation, now I'm going to substitute all these values here. So where's my u? My u now is f. I have my f multiplied by v. My v is exponential raised to the power of minus st. I put it exponential raised to the power of minus st. Then minus here as a minus integral. This is integral, your integration sign. Then my u is what? F. I have f times dv. My dv here is the differential form of this v, which is dv equal to minus s exponential raised to the power of minus st times t. So I will put it here. I say multiply by minus x exponential raised to the power of minus st times what? dt. So this one now is your dv. Now, what I'm going to do is that now this exponential here, this exponential is carrying a negative sign now. So by indices, I know that from indices, indices, I have my f. My f now will be e raised to the power of what? St. So if I apply my indices, this minus sign will change to what? Positive sign. So it will now be the meaning that my exponential will carry a positive sign, which is e raised to the power of st. So it's just like we have x raised to the power of minus 1. So according to indices, for you to change this minus sign to positive sign, it will be 1 over x, and that x now will carry a positive sign. So it's like taking an inverse of x. An inverse of x now will give you is equal to e, that is equal to x raised to the power of minus what 1. So now the same thing applicable to this exponential. So if you take the inverse, you will have f over exponential st. So minus, so now this is here I have a constant, and this constant is positive. So I'll bring it out from integration sign. So this one, this minus is here. Then this one, this constant is carrying a minus sign to be minus x. Then I have my integration sign. So if you remove x now, you have exponential raised to the power of minus st. Then you have your f here, f times this what dt. This is what I'm going to get if you remove minus x. So you're going to get this. Now, I know that this that I have minus here, I have minus. So minus times minus will give you what? Plus. So it will now be f over e raised to the power of st, then plus x. Then I have my integral sign of exponential raised to the power of minus st. Then I have my f dt. This is what you are going to get. So now I'm going to write this equation here. Then so finally this equation is already here. Then out from here now I will include my limits. Include the limits. If I include my limits, include what? Limits of integration. If you include limits of integration, the equation now will now be in this form. You now have f over e raised to the power of st. It will be like this. Then you put it in brackets. The limit now will be 0 to infinity. Mind you, this limit 0 to infinity is the value of what? T. So you now say plus x, then I have integral. If I put limit, that means this integral sign will also carry what? A limit. Then I have 0 to what? Infinity. So I have my exponential raised to the power minus st. Then f. If I include my limit now, this f now will be a function of what? T. Because it's a function of t. Because I'm having function of t here. Because this first one now is a function. This is a function. So it's a function of t here. So this f, and here you have the t. It means you're the f. It means your f is a function of what? T. So you have f of t times what? The t. So you're going to have it in this form by the time you include your limits. So now, having this, so I'll also evaluate this by using the infinity, include the infinity minus the minus 0. And that my infinity is where it's located where at the upper limit. The 0 now is located where at the lower limit. So it will now be upper limit minus lower limit. So I'm going to put it in this form. So it will now be f over that's exponential raised to the power of x. Our t here is what? Is infinity. I told you that your t's are 0 and infinity. So it will have a minus. Now this one is the upper limit. Then I'm moving to lower limit at a point where t is equal to 0. Then I have my f over exponential raised to the power of x times what? 0. So now I have my plus s. Then I have my integral sign 0 to infinity, then exponential raised to the power of minus st. Then I have my f of t times what? The t. So now, this first one now the upper limit. So this f over exponential raised to the power of x times infinity will give you exponential raised to the power of infinity. And mind you, exponential 1 over exponential raised to the power of infinity will give you 0. So you see that this first one now, I have f over e raised to the power of infinity, because it is infinity, because s times infinity will give you exponential raised to the power of infinity. And you know that f over exponential raised to the power of infinity mathematically is the same thing as f times 1 over exponential raised to the power of infinity, and 1 over exponential raised to the power of infinity is equal to 0. So the 0 multiplied by this f multiplied by this f will give you 0. So automatically your upper limit now becomes what? 0. So you see why the upper limit now becomes what? 0. So here is what? 0. I have 0 minus, then bracket. I have my f over, then this e raised to the power of x times 0, s times 0, because this e raised to the power of s times 0, and s times 0 give you 0. So you have e raised to the power of what? 0. So I have plus x, then multiply by the integral sign of 0 to infinity. To infinity, I have my exponential raised to the power minus st f of t times what? dt. So now I have 0 minus bracket f. I have f divided by e raised to the power of 0, and e raised to the power of 0 is 1. So I have my f over 1, then I have f over 1 plus x, then I have my integral sign of 0 to infinity, then I have exponential raised to the power minus st multiplied by f of t times what? dt. So now f divided by 1 give you f. So minus times this f will give you minus f. I have minus f plus x multiplied by the integral of 0 to infinity. Then I have my exponential raised to the power minus st multiplied by f of t times what? dt. This is what I'm going to get. So now, but my integral form of 0 to infinity, then exponential raised to the power minus st times f of t times dt will give you is equal to f of x. Is equal to f of x. So f of x, I have that f of x is equal to exponential raised to the power of 0 to infinity. I have my e raised to the power of minus st times f of t times dt. F of t times dt. So and I have my exponential raised to the power of 0 to infinity e raised to the power of minus st times f of t times dt here. So and this is equal to this. So I will now have minus f. But just that, know that this minus f is located where? At the lower limit. So at the lower limit now, the temperature now, sorry, at the lower limit, the time is what? 0. At the lower limit, you have time 0. So since is 0, so it will now be minus f of what? 0, because your t is 0, which is your lower limit. The value here t is equal to 0. So you have f minus f of 0 plus, you have minus f of 0 plus this x plus x, then multiply by what? Multiply by what? F of what? X. Because my f of x will give you this. So you substitute, you get f of x. So is equal to, so if you arrange it, you're going to have, is the same thing mathematically, it's the same thing as s f of x minus f of 0 will give you Laplace transformation of df over dt. This is the final answer. Give you, so this is what I'm going to get. This is what I'm going to get. So meaning that if you have Laplace transformation of dy over the t. It will now be s y of x minus y of what? 0. Then if you have Laplace transformation of the x over the t, it will now be x s of x minus x of what? 0. So this is how you obtain it. So that is it.